Hey guys, today we are going to talk about section 4.4. There are trig functions of any angles here. So we are going to be evaluating trig functions of any angle. If you remember back to 4.3, we only did angles in quadrant 1 or acute angles. So we're going to be doing that. We're going to find some reference angles and then evaluate trig functions of real numbers. Let me make this a little bigger for you. Okay. So the definitions of trig functions were restricted when we used acute angles. We were able just to say like, okay, here's a right triangle, here's x, y, and the hypotenuse. Now when we do it, we call the hypotenuse r because now we're over here in quadrant 2, okay? And the hypotenuse will be this diagonal, then your y will be the side coming down, and your x will be along the x-axis here. Okay, but now the whole point of this is the fact that x and y can be positive or negative now, where everything in quadrant 1 was always positive. So when it says r equals the square root of x squared plus y squared, just still think in order to find the radius, if you don't have it, it's like finding the hypotenuse. You're using the Pythagorean theorem. Okay, with the hypotenuse is isolated. That's all this is. Okay, so your definition, sine is still the y value over the hypotenuse. Cosine is x over hypotenuse. Tangent is y over x. And then their inverses follow suit just like they did last section. Okay, because the hypotenuse cannot be 0, it follows true that sine and cosines are defined for any real value of theta. However, when x is 0, tangent and secant are undefined. An example of that is the tangent of 90 degrees is undefined. Similarly, whenever y is 0, cotangent and cosecant are undefined. Those are things you can memorize, or you can just solve to find out those answers. When they're undefined, it's being divided by 0. Okay, as a nice little refresher here, the sine is the y value, cosine is the x value. So they tell you what sine they all are in each quadrant. So sine, cosine, and tangent are all positive in quadrant 1. Sine is positive in quadrant 2, and cosine and tangent are negative. In quadrant 3, sine and cosine are negative, and tangent is positive. And in quadrant 4, sine is negative, cosine is positive, and tangent is negative. Okay. So now I'm going to switch from our Google Slides over to my .cam. Okay, and we are going to talk about example 1. It says let negative 2, 3 be a point on the terminal side of theta. Find the 6 trig functions of theta. Okay, so let me make that so it's not so blurry. Perfect. Okay. So what we need to do, we know the x value, right? X equals negative 2. We know the y value, that's 3, but we don't know the r value. We need to solve for it. So the first thing we need to do is solve for r. Well, if you go back to slide 4, it says that r equals the square root of x squared plus y squared. Okay, so I'm just going to substitute and then simplify. Negative 2 squared is 4. 3 squared is 9. 4 plus 9 is 13. And that is in simplest form. I can't simplify that radical anymore. Okay, so I know r is square root of 13. Okay, and I just need to make sure that's positive and not negative. So if I have a negative 2, 3, if x is negative and y is positive, I'm in quadrant 2, right? So just keep that in mind when we're talking about sine, cosine, tangent, etc. Okay. All right, so find the 6 trig functions. Sine of, we'll call it theta, equals, sine is always the y value, so that's 3. Okay, cosine, 3 over r, right? Square root of 13. Okay, I need to rationalize this, so I multiply by square root of 13 over square root of 13, and I get 3 square root 13 over 13. Their sine. Cosine is the x value over r. Again, you need to rationalize. When you do that, you get negative 2 square root of 13 over 13. So sine is positive, cosine is negative. And to find tangent, I would start by just doing the unrationalized part. Tangent of theta is sine over cosine. So before I rationalize it, that was 3 over square root of 13 over negative 2 over square root of 13. The square root of 13's cancel out, and you're just left with negative 3/2 for tangent, which means cotangent is negative 2/3. Okay. And it's really easy to then go back and find cosecant and secant because they're just the reciprocal of sine and cosine. So cosecant is the reciprocal of sine. So I come back up here. Before I rationalized, it was 3 over square root of 13. If I flip that, I get square root of 13 over 3. And that's good because I don't have a root in the denominator. And secant is the reciprocal of cosine. So I come back up here to the original part before I rationalize, and I flip it, negative square root of 13 over 2. And that is in simplest form. I don't need to rationalize it because the root is in the numerator. So that's the first example in section 4.4. Okay, we're going to do other examples that are similar to your notes or to your homework here. Okay, this one says, given that sine of theta is 4/5 and tangent is less than 0, this means tangent is negative. Okay, find cosine and tangent of theta. Okay, so if I know, so I'll just kind of write some things that I know. If tangent of theta is less than 0, I know I'm either in quadrant, meaning it's negative. I'm either in quadrant 2 or I'm in quadrant 4. Okay. If I look at sine, so if sine of theta, and sine is positive, okay, the sine value is positive in quadrants 1 and 2. We need to figure out where they overlap, and that would be in quadrant 2. So I know that theta is in quadrant 2. Okay, so that helps me figure out what quadrant it's in, so that way I can assign positive or negative values to cosine and tangent. Okay, so then I can say if sine of theta is 4/5 and the definition of sine is y over r, okay, then I can say then y equals 4 and r equals 5. Okay. So I have to figure out which one I'm missing. So if I have r and y, I'm missing x, right? If I have my 3 letters that I need to be able to plug into my formulas. All right, so to find x, this is the hardest part. All right, I have the formula r equals the square root of x squared plus y squared. That's the formula they gave me to relate those 3 variables. Well, r is 5, so I plug that in. X I don't know, so I'm going to leave that alone. And y is 4. Okay. I need to solve for x, so this is just going back simple, some simple algebra. The square root is over everything inside, so I need to get rid of that first by squaring both sides. So I get 25 equals x squared plus, and this is 16. Okay, now it's a 2-step equation. I subtract 16. I'm just going to come up here and do it. 25 minus 16 is 9 equals x squared. And to get x by itself, we take the square root of both sides and we get a positive and negative 3 for x. However, we just need one of them. We said that this angle is in quadrant 2. And when you're in quadrant 2, your x value is negative. So we can conclude that x equals negative 3, not positive 3. Okay. And now they tell me to find cosine and tangent. Well, cosine of theta is x over r, so that's negative 3 over 5. That one's done. And tangent of theta, by definition, on slide number, I just need to go back and look, right? Slide number 3 is y over x. So y was 4, x was negative 3. Found both of them, I'm done. For example 2. Okay. Example 3. Evaluate the sine and cotangent functions at the angles. Okay, so there we go. These three angles are all on, if I look at the coordinate plane, here's 0. That's the point 1, 0. This is pi over 2. That's the ordered pair 0, 1. And down here is 3 pi over 2. And that's the ordered pair 0, negative 1. Okay, so before I did anything, I just wanted to show that. Okay, so if we're talking about 0, so if we're at 0, they want us to find, what do they want us to find? Sine and cotangent. Okay, well, sine is always the y value. Okay, in this case, we don't have a radius. We're not in the middle of a quadrant. So sine is just, so sine of theta equals 1. No, we're at 0. I'm sorry, 0. And cotangent is the reciprocal of tangent. So I'm actually going to find tangent first. So tangent at 0 would be y over x. So that's 0 over 1, which is 0. So if I want to find cotangent, I just need to flip that, which would be 1 over 0, which is undefined. So I just found an extra one just to kind of be able to get to my answer a little easier. If you have the definition of cotangent memorized as x over y, then you didn't really need this. Okay. At, what's the other one they asked? I'm gonna do pi over 2. Okay. The sine of that at pi over 2 is 1. And then I'm gonna skip straight to cotangent. Cotangent is x over y. So if you put x over y, that's 0 over 1, which is just 0. Okay, got my two answers there. And then at, I guess I should have left some more room here. 3 pi over 2. Sine will be, so here's 3 pi over 2. Sine is your y value. That's negative 1. And cotangent is x over y. So that's 0 over negative 1, which is just 0. Okay, and that would be example 3. Okay, now we're going to move into something called reference angles. And I'm not going to switch back over to the Google Slides because this is actually pretty clear. I don't need to. It says the values of trig functions of angles greater than 90 or less than 0 can be determined from their value at corresponding acute angles called reference angles. So what they're saying is as long as you have quadrant 1 memorized, you don't really need to memorize the rest of the unit circle as long as you know how to find a reference angle. Okay. So let theta be an angle in standard position. Its reference angle is the acute angle theta prime. So it's kind of hard to see. Looks like this. It's like a theta with an apostrophe after it. That means reference angle. Okay, formed by the terminal side of theta and the horizontal axis. Okay. Here is how you find the different reference angles. And I'm just going to refer back to the Google Slides because they show them with color a little bit better. Okay. So if you are looking and they give you an angle in quadrant 2, theta would be the angle from the positive x-axis over, and the reference angle is going to be from the angle down to the x-axis here. Okay, so depending on if you're given radians or degrees, here's your formulas on how to find it. If you're in quadrant 3, same thing. Here's theta. Here's the reference angle that's going down from the x-axis to the angle. Formulas on how to find it. And if you're in quadrant 4, the regular angle comes all the way around here, and then the reference angle starts at the angle and goes back up towards the x-axis. Okay, when you're in quadrant 1, you don't have a reference angle because quadrant 1 is what we're referencing. So back to our dot cam here. I'm not sure why this happened, but this kind of overlapped a little bit. No big deal. We can still kind of tell what they are. So it says find the reference angle for each value of theta. Okay, easy enough. So for A, 213 degrees. Okay, 213 degrees, the first thing you need to do is figure out what quadrant it's in. Is in quadrant, okay, so if I'm looking over here, I know halfway around the circle is 180, then 270, then 360, right? Each box is 90. So 213 is going to be in quadrant 3. Okay. And in order to find the reference angle for quadrant 3, you look down here and you do the angle minus 180. So I would do, say, the reference angle equals 213 minus 180. And when you do that math, you get 33 degrees. And I'm done. B is in radians, so it's just a little bit harder. So B, they're asking about 14 pi over 9 is in quadrant. Okay, I got to figure that out. So 14 pi over 9, the way I think about this is 14 ninths is 1 and 5 ninths. Right, if I just rewrite the fractional part as a mixed number, that means I'm over 1.5, 5 ninths. So I'm just trying to use my knowledge of fractions to help me. I know that's in quadrant 4. Okay. And given radians in quadrant 4, I'm looking over here, I would have to do my reference angle equals 2 pi minus the angle. So reference angle equals 2 pi minus 14 pi over 9. You need to find a common denominator. So I'm going to multiply 2 pi by 9 over 9. And I get 18 pi over 9 minus 14 pi over 9. And when I do my subtraction here, 18 minus 14 is 4 pi over 9. Okay. The one thing I didn't really touch on was part C. And I'm just going to kind of give myself some more room. So C here is negative 155. So I got to move this up. I need some more room. Right. Okay. Negative 155 degrees is in quadrant. And then I need to think about this. If I'm a negative 155, that means I'm in my coordinate plane. I'm starting at the positive x-axis and I'm moving clockwise, this would be 90, this would be 180, right? So this is negative 90 and that's negative 180. 155 falls in here somewhere. So I'm in quadrant 3. Okay. And you need to find what it's coterminal with. So it's coterminal, going back to section 4.1, with, remember to find coterminal angles, you take the angle and you add or subtract 360. So we're going to add 360 and get 205. Okay, so really this is the negative 155 degrees and 205 degrees are the same exact angle, except one's positive, one's negative. And then at that point, now I know I'm in quadrant 3. I've got my positive angle to find my reference angle in quadrant 3. I look up here. I'm in degrees. I do theta, which is 205, minus 180 to get 25 degrees. Okay, and that's my final answer there. All right. Moving on. Almost done. This is the last section that we're going to talk about here. All right. So now we're going to talk about how reference angles are used to help you evaluate real numbers. The only time you really need to do this is if you don't have the unit circle memorized. During this class, you will because you're able to use it. So I'm only going to do a couple examples here to help you out. Okay, we're going to look at slide 16. Okay, but what it says is the sine of theta and the sine of your reference angle are going to be equal. Okay, the only difference might be the sign. Okay, the sign as in positive and negative. It all determines, the only thing that determines that is what quadrant theta is in, or the angle is in. Okay, so in this box you'll see it says, define the value of a trig function of any angle theta, determine the function value associated with the reference angle, and then depending on what quadrant it's in, affixate the appropriate sign to the function value. Okay, slide 17 just gives you a breakdown of some of the, of the angles in quadrant 1, so what your reference angle will be, and their sine, cosine, and tangent values. All right, so for, I'm only going to do a couple of these. I'm not going to do all of them. So let's talk about A, okay? A says the sine of 7 pi over 4. So we could say because 7 pi over 4 is in quadrant 4. If you look at your unit circle, that's where it will be. Okay, you can find the reference angle by taking 2 pi and subtracting your angle. Okay, I am not going to show finding a common denominator and all of that. At this point, you should be able to do that. And when you subtract, you get pi over 4. Okay, pi over 4 is your reference angle. Reference angle. Okay. What that means is whatever the sign is of pi over 4, we're going to use that value for 7 pi over 4. We just need to make sure we have the right positive or negative value on it. Okay. We can say sine is positive in quadrant 4, right? So in quadrant 4, I just started writing that and I realized that's wrong. Sine is negative, isn't it? In quadrant 4, so if you're in quadrant 4, you're down here. Y is negative down there. Got a little ahead of myself. Sine is negative in quadrant 4. Okay, so you could say that the sine of 7 pi over 4 equals the negative sine of pi over 4. And the sine of pi over 4 is square root of 2 over 2. So your answer is negative square root of 2 over 2. Okay. You could also just have the unit circle memorized or look at your unit circle in this case because you get to use it. I went over this section in detail when students were not allowed to use their unit circle on the test. Okay, but that is it for section. Actually, I'm going to do one more example. Sorry, kind of got away from myself. I want to do one more. It's example 6 in your notes. Okay, because they want you to find, so they give you the sine value of -4/5, and they want you to find cosine and tangent by trig identities. So when we did examples 1, 2, and 3, we just used the definitions. The identities are things like sine squared plus cosine squared equals 1, and so on. So that's exactly what I'm going to use here. A trig identity would be sine squared plus cosine squared theta equals 1. The reason I did that is because they tell me to find cosine and they gave me sine. So I have both those things here. Okay, there are other ones you could use if you needed to. So I would plug in sine -4/5 squared plus cosine squared equals 1. And now I just start solving for cosine. Remember, you can rewrite cosine squared theta as cosine of theta all squared. It means the same exact thing. Here, when I simplify this, I get 16 over 25 plus cosine squared theta equals 1. I start solving. Cosine squared theta equals 1 minus 16 over 25. Okay, and then to get rid of the squared, I have to take the square root of both sides. So you'll notice I haven't started to simplify under that root yet. Okay, at this point, now that cosine is by itself, I'm going to. Okay, if I want to subtract, I need a common denominator, so this would be 25 over 25. So 25 minus 16 is 9. Okay, so I simplified under the square root. Now I take the square root of both the numerator and the denominator. The square root of 9 is 3. The square root of 25 is 5. And I know if I take the square root, I get a positive and a negative value. Okay. However, it tells me up here that I'm in quadrant 3. So if you are in quadrant 3, you know that cosine is negative, that sine is negative, and that tangent is positive. If you don't know that, think about what the x value here is negative, the y value here is negative, and then a negative divided by negative is a positive. Okay, so I know cosine's negative, so my actual answer is going to be cosine of theta equals -3/5, right? I don't need the positive on there, so that's the first answer. And then the other thing they asked me for is tangent, and I know the definition of tangent is y over x, or sine over cosine. So sine is -4/5, cosine is -3/5. The fifths cancel out, and the negatives cancel out, and I'm just left with tangent of theta equals 4/3. And now I am done with section 4